JavaScript has comparison and logical operators. This allows our program to think, to compare two things, and produce an output depending on how that comparison worked out. This allows our application to be logical. In fact, your mind does this on a daily basis. Take, for example, you crossing a road. Now, when you come to the road, you'll go ahead and look on the road and you'd say, is there a car there? True or false? If it's true, there is a car there, then we can perform an action or not perform an action, such as if there is a car there, stand still. There's no action, there's nothing returned. If, however, it's false, there's no car there, well, now what we can go ahead and do is perform an action. We can return an action and cross the road. Now, your mind doesn't think like that. You're not thinking true or false, look left and right and see if a car's coming, true or false on both sides. If both of them are false, then cross the road. That may seem like a long-winded way to think about it, but that's actually what your mind is doing. It's just simply comparing situations, and in a safe situation, it will allow you to cross the road, and in a dangerous situation, you don't cross the road, you stand still. So in either case, what this logic allows us to do is perform actions, and we have many actions, potentially not with such disastrous results, but we still have many logical operations that we do throughout the day. And so our programs are the same. In order for our programs to adapt to certain situations, to certain data that we give it, we need comparison operators. So we can compare data, compare situations, and then perform an action based on the comparison. Now, we don't need to do any kind of special setup in order to find out if the conditions that we write are true or false. We can simply write out conditional statements right in the console window, and it will return true if the condition was met or false if the condition was not met. So what we want to do is first of all take a look at the double equals comparison operator. Now, something I want you to note is that we are putting in two equals here. One equals means that you are assigning a value. This is for when you're creating variables and you want to assign a value to that variable. Same goes for properties in your object and so on and so forth. So a single equal sign on its own is called an assignment operator, and we've had a look at a varying degree of assignment operators. Please do not get this confused with the double equals. Double equals is a comparison operator, meaning it will compare what is on the left-hand side of this operator to what is on the right-hand side of this operator. And what we're doing is we're saying compare them, and we want to see if their values match. So is what's on the left-hand side, which will be, let's say, a number 20, equal to what's on the right-hand side, which will be 20. Now, what will this statement produce? We know that this condition is true just by looking at it. They both are equal, they balance. So, as they have the same value, this conditional statement will return true. Now, your conditional statements return a Boolean value. True if the condition is met, or if the condition is not met. In this case, the condition is not met. 20 is not equal to 21, and therefore we get false. Sorry, this condition wasn't met. They're not equal. So you will either get true or false depending on whether your conditional statement was met. Now, what I want to do is compare strings. So I can say, is hello equal to hello? The answer is true. So what it does is it compares, number one, the length of the string, and it also compares the characters of the string as well. So it's case sensitive. So is hello with a lowercase h equal to hello with an uppercase h? The answer is false, so this is case sensitive. And also you can compare Boolean primitive data, so is false equal to true? And the answer will be false. They are not equal. But however, is false equal to, let's say, false? Yes, those primitive data types match. So this is quite nice. You can go ahead and try others as well. So don't forget you have the null primitive. So I can say is null equal to null. Yes. Is undefined equal to undefined? Yes. And this is also nice when you want to determine whether a variable is null or undefined. So if I create a variable, let's call it A, and just end it there, I've now got A. A is undefined. So if I say, is A equal to undefined, I'll get true. Or if I say, is A equal to null, I will still get true. Don't forget, undefined and null are kind of the same thing. And using the equals operator does allow for that nicety in there where you don't really have to be that specific of undefined or null. And likewise, null is equal to undefined, and undefined is equal to null, of course, if you just swap that around. Yes, they are equal. So what I can go ahead and do now is clear the console. Now I want to talk about polymorphism. Usually this is quite complex and you go, oh, there's that really big word there, but polymorphism occurs naturally in the world and also in programming. Polymorphism is a lot like adaptation, adapting to what it's been given. So for example, we've already experienced polymorphism with the plus operator. So for example, I can add two numbers together. I can also use that same operator to concatenate two strings together. This is polymorphism. On top of that, I could, let's say, have a number and a string. And again, the plus operator deals with these different data types. And in that dealing, that is the adaptation of this data, it produces an output that we expect. So this is what polymorphism is. Now let's take a look at the double equals comparison operator and how that polymorphs our statements. For example, let's have the number 20 and check to see if it is equal to the string 20. What will you expect? Well, as we've just spoken about polymorphism, be careful not to say false, because we have a number data type and we have a string data type, but it will in fact return the value of true. Now, ECMA have defined the standards for this polymorphism. Basically, it is if you are trying to compare, let's say, a string and a number, then in this case, what it actually does is it converts the string into a number, because you cannot possibly compare a number to a string. You can't do that. So one of these data types is going to have to be changed. And it turns out it's the string that changes to a number. And so what happens is it took that value out of the string and tried to convert it to a number. So it said 20 equals 20. Now they're both the same data type. And then it produced the value true. And likewise, if I said, is 20 equal to, let's say, 21? Well, that's going to be false. Now, what happens if I was to, let's say, include some characters in here? So I said, is 20 equal to hello, da da da. Well, what you're going to get is false, of course. But how did it actually convert it? Well, what it asked it to do was, let's say, parse an integer. Now, don't worry about this function right now, but I want to show you what JavaScript did. Was it took that value and it tried to convert it. What did we get back? We got back nan. So it's like saying, is 20 equal to nan, which is not a number, don't forget. So this tried to convert it and said, no, it's not even a number. And so it will, of course, give you false. And nan is a primitive data type, don't forget. So that's the kind of example of polymorphism that happens with this comparison operator, which is the double equals sign. And likewise, is false equal to 0? This is something that's really weird in JavaScript, but again, this is an example of polymorphism. We have two different data types. However, in JavaScript, it does actually say true. False is actually equal to 0, and true is equal to 1. That will return true. And just to show you that it's not just because we're writing false right here. If I say false is equal to 1, which we know false is only equal to 0, it will return false. Sorry, false is not equal to 1. However, false is equal to 0. It gave us true. Likewise, null is equal to undefined. Technically, they're two different primitives. They have two different names. One's null, one's undefined. But with the equals equals operator, it polymorphs and says, well, null is technically exactly the same as undefined. So that's a little nicety there. But what if we want our applications to be a bit more rigorous when doing a comparison? AKA, no trying to adapt to the data you're giving it. Take the data types that you have been given, whether it be a number and a string, and leave them alone. And that way, you are not only comparing the values, such as this, you are comparing the types. So let's go ahead and take a look at the triple equals operator. The triple equals operator not only compares value, but it also compares type first and foremost. So if I say 20 is equal to, and this is a strict equals now, the string 20, the data types don't match. The one on the right is a string and the one on the left is a number data type. Therefore, it will equal false. And I can go ahead and say, is the number 20 equal to the number 20? The answer will be true, because they both match in the data types, they're both numbers, and they're the same value as well. So that's what happens with the strict equal sign. And you'll notice that null under the strict equal sign is not the same as undefined. It's not allowed. Technically, they class as two different primitives. False is no longer equal to 0. Because they're two different data types. And the same goes for true isn't equal to 1 and so forth. So there's no adaptation. There's no having to deal with different types of data. I recommend whatever you do, try to use the equals 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 operator. The reason being is because it doesn't play around with the type and it ensures that your application is being a bit more strict when it comes to the data type. You're not asking it to polymorph. You're not asking it to adapt the data if the data types don't match. That way, your application has more rigidity. And the more rigid your actual application becomes in the sense of comparing data, the better off you are. However, the only exception that I would make onto this is the fact of if you were checking a variable, let's say, so I want to check A is, let's say, undefined. I would actually recommend getting rid of the triple equals. And the reason why is because undefined could either be undefined or null. And in that case, it will say, okay, well, undefined and null, it's the same thing. So if I hit return, you will notice that it says true. I could also say, is A equal to null? And it will also give true. If I said A equals 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 null, I will get false, because when I try to call A, you'll see that this browser says, well, it's undefined. It's not technically the null value. So I would recommend if you were checking to see if something was empty, undefined or null, just use the double equals. For everything else, use the triple equals. Now we can also check to see if two values do not match. This would be nice for, let's say, a quiz. So let's say I want to check to make sure the answer that was given by the user is not equal to the correct answer. So this is good for multiple choice because we may not know what the user is going to type in for their answer. So all we want to do is make sure that it's not equal to the correct answer, and that will let us know if they got the answer wrong. So in this case, this string is not equal to this string. Hit return, it will say true, which means the left side doesn't equal the right-hand side. They're not the same. So we can say if it's true, then you can print an error message to the user and say, look, you got the answer wrong. Now I can also say if the user has given me the correct answer, so the user has inputted this answer, and I'm going to make sure it's not equal to the correct answer. Now in this case, it will say false. That's because both sides on the left and on the right are equal, and therefore this is invalid. They are not equal. They are equal. And therefore we get false. Now, that's good because then we can say, well, if we get a false value, then we can print out a string to say, you got the right answer. So that's why it's good to sometimes say, is it not something? If we know what we want, and if what we've got is not what we want, then we can perform an action. Now also, just like with the double equals, the exclamation mark equals polymorphs. So it's only going to check the values and it will try to change a string into a number. For example, does 20 not equal the string 20? It says false. So 20 in this instance does equal 20 because it changed that string into a number. And therefore this statement is false. They're supposed to unbalance. If they unbalance, we get true. If they're balanced, we get false. So this can be a cause for concern. So what I can do is, just like we had the double equals that polymorphed, we also had the triple equals. Well, now just take out the first equal sign and replace it with an exclamation mark. So this operator is simply saying, is what's on the left-hand side not equal to the value and type? So they both have to not match in terms of type and value. Well, now, if I say the number 20 is not equal to the string 20, it will say true. They're not equal. One's a number, one's a string. There's no polymorphism, no converting a string into a number. It just gives us the value of true. So that statement is true. Likewise, if I took that off and said, does the number 20 not equal the number 20? Well, that's false because 20 does equal 20. Next up, I want to take a look at the greater than comparison operator. So what we're doing is we're saying, is what's on the left-hand side of this operator greater than what's on the right-hand side? Just like in mathematics, so I can say, is 20 greater than 5? It'll give me true. 20 is greater than 5. If I say, is 2 greater than 5, we'll get false because 2 is not greater than 5. Likewise, I could do the reverse and say less than. Is 2 less than 5? So is what's on the left-hand side smaller than what's on the right-hand side? I'll get true. And then also we have 20 less than 5. And we'll get false because 20 is greater than 5. Now, an easy way to remember this, because I do sometimes just have brain farts for some reason and can't understand which symbol's which, just remember you read a book left to right. So you start reading from the left, and when you come to the bigger side, the one that's further apart, that's greater than. And the one where you start reading from the left and you come to a sharp point is less than. It's just a way that I always remember it, and then once I've learned it, you never really have to learn it again. So I'll go ahead and clear that out. Now, you don't also have to have the greater than and less than on their own. You can also have greater than and equal to, and less than and equal to. So for example, is 5 greater than 5? The answer is no, 5 is not greater than 5. 5 is equal to 5, but it's not greater than. So what's on the left has to be, in this case, 6 or more, because we've got 5 on the right-hand side. So this has to be 6 or more for this statement to be true. Well, we can say, is it greater than, is 5 greater than or equal to 5? Hit return and we'll get true. Not because it's greater than, but because it's equal to 5. So that's the greater than and equal to. The same with less than. Is 2 less than 2? No, the only way this is possible if this was potentially 0, 1, or a decimal number such as 0.55555 and so on and so forth. So it has to be less than 2 for this to be true. So we could say, is it less than or equal to? So is this number on the left less than, which it's not, or equal to? If it's equal to 2, it will return true. So that's just a nice little variation of that operator. And as I said, with this operator, you do kind of have to be careful. There's no sort of strict typing with this. And you do really want to make sure that what's on the left-hand side and the right-hand side is a number value. If it's not a number value, then we can have problems. So it's always best to make sure that you work with numbers only when it comes to greater than, less than, greater than, equal to, and less than and equal to operators. So there we go. There are the operators that allow us to ask questions. But now what I'd like to do is use these operators and actually program some functionality.